What's going on, guys? Today we're tackling exponential derivatives. Now, much like last time, I have 10 questions prepared for you, which is linked in the description below if you want to answer it for yourself. But I will be here to answer them for you. Before we start, let us check the identities of exponential derivative of the exponential functions. Uh, the most important number here is the number e, which is around 2.71828, about this one. 2.718281828 and so on and so on. It doesn't repeat. There's other numbers there, but that's the first few numbers. So that's what e is. So the derivative of e to the x is e to the x, which is everyone's favorite derivative. Okay. And the following here are examples of the exponential identities. So for example, e to the ln x is x. Ln is the logarithm base e of x. So if you raise e to a logarithm, you'll get the input, which is going to be x. So that leads into the next situation, which is a to the x. We can change that into the a into e to the ln a. Then we can multiply x and ln a, so we will get e to the x times ln a. That will be important later on. We have here e to the x parentheses, then squared, then that is equals to e to the 2x. All right, and then we have the addition and the subtraction rule, and we're going to tackle everything else that we need as we move on. So let's move on to the first question. But before we move on to the first question, let us prove why the derivative of e to the x is e to the x. So we have f of x is equals to e to the x here. So actually, why is e 2.718 whatever, right? That's a bit weird. So let's define what e is in terms of the limit. So if you remember, the e is actually the limit as h goes to infinity, 1 plus 1 over h to the power of h. That is the definition of e. Or you could actually do some little bit of substitution. You can also express e as this: the limit as h goes to now 0, 1 plus h to the power of 1 over h. This is also e. That's going to be important later on. So let's try finding the derivative of e using the definition of the derivative. So we get the derivative of x is the limit as h goes to 0 of e to the x plus h minus e to the x all over h. We can split the e to the x plus h with the identities earlier, so we can say this is limit as h goes to 0 of e to the x e to the h minus e to the x over h. Now there's e to the x here, there's e to the x here, so we can extract that outside. So the limit as h goes to 0 of e to the x, and then we get e to the h minus 1 over h. Now we know e is this, so we can substitute this for e. But let's check. This, the h approaches 0. In here, the h also approaches 0. So that's the one we're going to use. It has to approach the same values, so we can use, yeah. So we get e to the x, the limit. We can bring e to the x outside since it's just a constant with respect to h. So e is 1 plus h to the power of 1 over h to the power of h, which we can multiply here, minus 1 over h. So we can cancel this, and then we're left with 1 plus h minus 1 all over h. The 1 here and the 1 here cancel. That leaves us h over h, and which is just 1. So in the end, the answer is e to the x. So the derivative of e to the x is e to the x, and that is the important fact of the day. So let's go to the first question. Question number 1. Y is equals to e to the 2x cubed plus 8. This is just a chain rule situation, so it's very easy. So what you have to do is to find the derivative, you have to find the derivative of the outside first, which is, let me underline it here. And then the inside is going to be this one. So let's find the derivative of the outside. It's e to the sum to the same thing. So 2x cubed plus 8. And then we multiply by the derivative of the outside, which is going to be 6x squared. That's it. Let's rearrange this a bit better. 6x squared e to the 2x cubed plus 8. And there we go. That's the answer. Question number 2. Y is equals to x e to the x. And we're tasked to find the 10th derivative of there. If we're trying to find the 10th derivative of something, and this looks messy because we need to do some product rule situation here. So we need to find a pattern in order to get the 10th derivative. So let's try looking for a pattern by finding the first derivative first. So the first derivative, well, this is just a product rule. So this is the u, this is the v. So product rule is just derivative of the first, derivative of x is 1, and then multiply that by the second. And then we add that by the first times the derivative of the second. Derivative of e to the x, as we said, is just e to the x. So let's rearrange this to get x times e to the x plus e to the x. We have x e to the x here. We have x e to the x here. So welcome. It's a welcome change here. So finding the second derivative, we get that this is going to be well, what's the derivative of x e to the x? We already established that it's this. So we can copy that. X e to the x plus e to the x. And then we add e to the x here. Since, we have to find the derivative of e to the x. So we add e to the x here since that is the derivative of e to the x. So the final answer is x e to the power x plus 2ex. I can see a pattern here, but let's try one more time. Third derivative, x e to the x. What's the derivative of x e to the x again? Again, that's x e to the x plus e to the x. And then we have to add by the derivative of 2e to the x, which is going to be constant 2 times e to the x. What's the derivative of that? E to the x. So this is going to be x times e to the x plus 3e to the x. You can see the pattern, right? So the first derivative, it's x e to the x plus 1 e to the x. And the second derivative, the 1 changes to 2, and then third derivative is going to be 3. So we can conclude here that the 10th derivative is going to be x times e to the x plus 10 e to the x. And that's the answer. You only need to find the pattern. It's not that hard. You just need to find the pattern. Question number 3. Y is equals to x, e to the x secant squared x over x, e to the x tangent squared x. Now, should we use the quotient rule here? Maybe, but no. No, don't use the quotient rule here because there's an easier way around this one. Remember the exponential identities earlier. So this is a quotient. So we can say this is also e to the power in the numerator, x secant squared x. Then we subtract that by the power in the denominator, x tangent squared x. And that's valid. That's the same thing. We can extract x on the outside, so we can get e to the x times secant squared x minus tangent squared x. What do you know? Secant squared x minus tangent squared x, that's just equal to 1. So this is equal to e to the x times 1. The derivative of that is going to be e to the x. And that's your answer. That's it. So we don't need some tricky, quotient, chain rule, whatever. You just need to know the identities by heart. Yeah, it's not an easy task, but if you know it, you can make your life easier, I guess. Question number 4. Oh, this is implicit. E to the xy is equals to x squared sine y. Okay, so there's no brute forcing. I mean, there's no identities to be had here. This is pure brute force. There's an exponential here. There's a polynomial here. There's a trigonometric. This is gonna be tricky. So let's try finding it one by one. So the derivative of e to the something is just e to the something. E to the xy. Then we multiply it by the derivative inside, chain rule. So we get derivative of x is 1. Then we multiply that by y, product rule. And then derivative, well, first we write x, then derivative of y is 1. And then y prime, since they're finding the derivative in terms of x. That's it. And then for the next part, derivative of x squared is 2x. Sine y is just sine y. And then we add by x squared, then derivative of sine is cosine y, and then y prime. Move every y prime term to the one side, so we get x e to the xy y prime minus x squared cosine y y prime equals 2x sine y minus y e to the xy. All right. So let's try isolating y prime from this one. So we get x e to the xy minus x squared cosine y, then y prime, equals 2x times sine of y minus y e to the xy. Y prime then is equals to 2x sine y minus y e to the xy over x e to the xy minus x squared cosine y. There we go. And that's the answer. That's very long, but yeah. You gotta do what you gotta do. Alright. Y is equals to, let me put the number first. So yeah, we don't get confused. This is question number 5. Y is equals to 12 to the x. Find y, the nth derivative of y. So we need to find the general form of the nth derivative of y, so that when we insert n here, we get the nth derivative. So how does that work? So we need to see e here. This is 12, not e. So how do we find e again? So we can use the identity that e to the ln 12 is equal to 12. So we bring that to the power x. We multiply the powers in order to get e to the x ln 12. That's going to be one of the, this is going to be our equation for today. So that's much easier to see, right? So because there's e to the x, and that's just ln 12 is just a constant multiple, so everything's fine. So y prime, what about y prime? This is equal to ln 12, right? Then we multiply that by e to the x ln 12, right? So what happened here is that we found the this is just chain rule. So the derivative of e to the x ln 12 is e to the x ln 12. Then we multiply by the derivative inside, which is going to be ln 12. So let's try finding the second derivative, if you can see a pattern. So ln 12 multiplied by e to the x ln 12, and then we multiply by ln 12 again here, since that is the derivative of the inside here. So that's it. So this is ln squared of 12 e to the x ln 12. You can see, right? First power, there's power 1 here. Second power, there's 2 here. Would it be a surprise if in the third derivative it's the third power there? No. So we can say that y, the nth derivative of y is ln to the power of n 12 e to the x ln 12. Or if we want to be clean, this is ln n 12 times 12 to the x. There we go. So just put the n there, and that's the nth derivative for you. Alright. Number 6. Y is equals to e to the x ln x. Find y triple prime. I don't think there are identities here that we could use to our advantage. So let's just brute force this. So y prime equals to, this is u, this is v. So u, derivative of u is e to the x. Then v is ln x. Plus u is e to the x. Derivative of v is 1 over x. Alright? This is e to the x ln x plus e to the x over x. Correct? Correct. So y double prime, this is equal to the derivative of e to the x ln x. We know this is the derivative of e to the x ln x. We just found that earlier. So just copy that, e to the x ln x plus e to the x over x, and then the derivative of e to the x over x. What's that? So that's going to be a quotient rule situation. So the bottom is x squared, and then the top is going to be derivative of the first, e to the x times x, minus e to the x derivative of second, which is going to be 1. So let's try e to the x ln x times e to the x over x plus x e to the x minus e to the x over x squared. Y triple prime, this is going to be very long, but bear with me for a moment. So this is plus. So e to the ln x, we know that is e to the x ln x plus e to the x over x. E to the x, the derivative of that is this. So x e to the x minus e to the x over x squared. For the derivative of this, it's going to be very long. So let's simplify this one further. This is x minus 1, then multiplied by e to the x over x squared. I hope that's easier. Let's try on another layer. So we're trying to find the derivative of x minus 1 times e to the x over x squared. What's the derivative of that? Well, this is just another quotient rule situation, but much harder. So we squared the bottom, so x to the 4. So the derivative of the top, what was the derivative of x minus 1 times e to the x? God. So is I created this question. What the hell? So x minus 1, that is 1 times e to the x plus x minus 1, then multiply by e to the x, since that is the derivative of e to the x. So that's it. So we get x minus 1 e to the x plus e to the x. And this is going to be actually let's clean this up before, or actually I thought of a way to simplify it. So this, you can extract e to the x from both sides. So this is 1 plus x minus 1. 1 minus 1 cancel, and then this is going to be x e to the x. So it's just going to be x e to the x, the derivative of the top. Then we multiply by the bottom, so x squared, minus the top, x minus 1 e to the x, multiplied by the derivative of the bottom, 2x. That's going to be x cubed e to the x minus 2x, x minus 1 e to the x. I put the e to the x in the wrong spot. There we go. Over x to the 4. Notice both of them have the x term. So we can multiply 1 over x to both sides, I think. So we get x squared e to the x minus 2 times x minus 1 e to the x over x cubed. And that's going to be the derivative. If it's wrong, please contact me. I don't know if it's correct. So that's going to be the answer. Let me just, it's a bit messy, so pardon. Plus, hold on, let me see again. X squared e to the x. Okay. X squared e to the x minus 2 x minus 1 e to the x over x cubed. There we go. Pray that this doesn't appear in the exam, because it's going to be very, very difficult, or at least just the first derivative. I don't want that being the third derivative. I don't want to find the third derivative. But anyway, number 7. y is equals to x e to the x minus 2. Sorry. Plus 4x e to the 2 minus x. Can we do anything about this? I don't think we can, because we can multiply by e to the x minus 2 minus x doesn't really fit. It would be negative, so it would be in the denominator, which won't be. You know what? Why don't we just brute force it? Maybe this is just not a nice answer, you know. So y prime is equals to this is another product rule situation. So we start with the derivative of the first 1 times e to the x minus 2 plus x times e to the x minus 2. Derivative of x minus 2 is just 1, so we don't have to touch that. Plus derivative of the another product rule situation. Derivative of the first is 4, then e to the 2 minus x, and then plus 4x e to the 2 minus x, and then the derivative of 2 minus x is negative 1 now, so we have to pay attention to that. So rearrange this a bit. E to the x minus 2 plus x e to the x minus 2 plus 4e to the 2 minus x minus 4x e to the 2 minus x. Let's group them together so we won't get confused. We get 1 plus x e to the x minus 2 plus 4 minus 4 times, let me just 4 1 minus x, we extract the 4 on the side, e to the 2 minus x, and there we go. That's the answer. If it's wrong, please call me out, cancel me on Twitter, I don't know. Anyway, number 8, x to the power of e to the power of x y. That is not we don't multiply the powers here, so that is e to the xy on the top. So yeah, equals sine of what? Oh Jesus, what? Okay, jeez. Anyway, sorry about that. Sine of, let me just look, y e to the x. So what's going on here is a mess. So let's just try finding. Oh no, this is well, look at this. So it's x to the function power, so we can't minus 1 and then to the front. So we need to find the logarithm of this. So ln on both sides, we get e to the x. Wait, hold on. I think it hasn't charged it. Sorry. So e to the xy ln x is equals to ln of sine of y e to the x. It's a complicated. That is very complicated. But let's try trudging along. So this is a product rule situation. So e to the xy. The derivative of that is going to be xy is y plus xy prime, as we discussed earlier, ln x plus e to the xy over x. 1 over x is the derivative of ln, and this is equal to, this is a huge product rule chain rule situation, so 1 over sine of y e to the x, multiply that by, let's remove the one here, multiplied by cosine of y e to the x, multiplied by the derivative of the inside, so y prime e to the x plus y e to the x. It's kind of difficult to write. Yeah, so let's isolate everything that contains y prime to the left, contains the nothing, no y primes to the right. So x ln x e to the xy y prime minus the 1y prime here is in this part, I can't fit it in, e to the x we can simplify this as cotangent of y e to the x, correct? And then this is going to be y prime. This is equals to, let's put it on another line. We're struggling for space. This is equal to uh let's put this let's focus on the ones here. Y e to the x cotangent of y e to the x. Hey, look at that. And then subtract by this one, e to the xy over x. And then we subtract by this y e to the xy ln x. Let's put the answer on another layer. Let's put this. Let's bring this. Why not? It's Photoshop. I can bring it to the other side. Hold on a minute. You know what? Never mind. So yeah, that's the it's problematic. Anyway, wait la, hold on. Let me just move this one. There we go. Moved it. And then let's draw on this layer. So that's what we have. So let's group y prime. I am not in the mood today. Anyway, I'm so sorry. Y prime is then x ln x e to the xy minus e to the x cotangent y e to the x equals to y e to the x cotangent y e to the x minus e to the xy over xy e to the xy ln x. I sound like I'm saying nonsense here, but it makes sense. Trust me. Why not multiply x while we're at it on all sides so we can remove this? So let's put x here, remove this x, and then let's put x. This is squared, this is x. So we can just erase the x on the denominator. So we don't have any denominators in here. So y prime is now equals to, well, we don't have any complex fractions at least. So is it correct? But I feel like there's something missing there. Let's see. Oh, I forgot about, I think, yeah, I forgot about minus here, and then should be x there. Okay, sorry about that. I forgot about. Let me just move this up. All right. Sorry about the mistake. So this becomes xy e to the x cotangent of y e to the x minus e to the xy minus xy e to the xy ln x over x squared ln x e to the xy minus x to the e to the x cotangent of y e to the x. I think I just summoned the demon, but that is the answer. Whew, I do not want to touch that question again with a 10-foot pole. Anyway, that was question 8. So we had question 9. Oh, this is going to be interesting. Y is equals to 2 sine x plus e to the sine x. Well, 2 sine x, we can take care of that simply because that's just easy one. So this is going to be 2 cosine x. Derivative of sine is cosine, as we discussed earlier in the previous video. So this, first we need to find the derivative of e, and then sine x, then x. So e to the sine x first, multiply by the derivative of that is cosine x. Let's group this together so it looks clean. So cosine x, and then 2 plus e to the sine x. That's the answer. Now, question 10. Let me just Let me just have a screenshot of it for you. I have it on Word. Uh, there we go. Question number 10. The half-life decay of a radioactive isotope of a material is represented with the equation a to the power t is equal to and then not a to the power t, a of t is equals to a of 0 e to the negative kt, where k is equals to ln over thl, where a of 0 is the initial amount of the material, at is the amount after time t, and thl is the half-life of the material. If the initial amount is 100 grams, and after 3,000 years, it has reduced to 15 grams, find the rate of the change of decay dA over dt. So this might sound familiar to you, especially for those taking up chemistry, because this is taken from that subject. I just stole a question there. So the equation is a of t is equals to a of 0 e to the negative kt, where k is equals to ln 2 over t half-life. All right. So we need to find the values of k first. We know a0, we know at, we know t, we don't know k. So basically we have to what we're trying to find actually is dA over dt. That is found by finding the derivative of a to the t, since the derivative of that is dA over dt. So t is taken care of. We just need the value of k. So we do need to find k first. So let's have this one. So a to the t, let me pull up the question earlier. A to the t, or the amount after 3,000 years is 15 grams. The initial amount is 100 grams. So A0, A0 is the 100 grams. This is 100 grams. We need to include the unit here. Then 80 is 15 grams, which is the amount after 3,000 years. Speaking of 3,000 years, we can find that using here, 3,000 years. So in order to isolate k, we need to just isolate k in order to find the value of k, because that's the only thing missing here anyway. So what we need to do is isolate k. So I already written that out then, but to isolate k, we do need ln of 15 grams over 100 grams times -1 over 3,000 years. So what happened here is we divided both sides by 100 grams. That's the 15 over 100. And then we took the natural logarithm both sides, so we can remove e. And then we divided both sides by -1 over 3,000 years so that we can isolate k. So that's what's going on here. So the answer is 0.00140 inverse year, which is the k, the rate constant k. It's just a constant, so whatever unit it is, we don't care really. So next part. This is k. So let's proceed to the next part. At, which is the function we're looking for, is equals to the initial amount is 100 grams. So we put 100 grams here, and then multiply that by e to the negative 0.00140 inverse years 1 times t. All right. What does inverse years doing here? What is it doing here? You might ask. Well, let's just wait. So let's find the derivative of this. dA, a is the amount, over dt, the time, is equals to 100 grams remains there since it is just a constant multiple, a coefficient, times then we multiply this by, let's put it here, e to the negative 0.00140 inverse years times time. Then we multiply by the derivative of the inside, which is going to be this one. This is the outside. So the inside, The derivative of that is, well, t, and then this is the constant. So this is going to, or coefficient, sorry. So this is going to be multiplied by negative 0.00140 inverse years. And there we go. So simplify this further, we get negative 0.140 grams per year times e to the negative 0.00140 inverse years t. And I told you the inverse years was important there. So it now is a gram per year situation. Why is that important? Because remember dA over dt? dA, A is the amount. So it's the change in amount over the change in time. Amount over time, gram over year. That's essentially what we're looking for. So we are on the right track. So we just need to find out the decay in the present moment, which is 3,000 years from the past. So we get negative 0.140 times e to the negative 0.00140 inverse years times 3,000 years. The inverse year and the year cancel each other. That's good. And then gram per year. What happens? The answer is negative 2.099 times 10 to the negative 3 grams per year. So that means at the present moment, 2.099 times 10 to the negative 3 grams are lost on the radioactive material per year. And so that's the radioactive decay rate today, on the present moment. But you know we're not gonna finish off with just 10 questions. We're gonna finish with an 11th question. Y equals e to the x power series. So what's the power series of e to the x? Well, if you watched the 75 questions that I posted here, which you probably haven't, but the last question is actually the power series of sine of x, which is the Taylor series of sine of x. So if you don't know, the Taylor series, you get the a transcendental function, for example, e to the x, sine x, cosine x, whatever, a transcendental function. And then you express it in terms of an infinite polynomial. You can do that for certain functions. So e to the x is no stranger. We can express this in terms of infinite series. This is actually equal to the summation from n equals 0 to infinity of x to the n over n factorial. So that's the representation of e to the x in terms of an infinite polynomial. That's just a shortened version of it. So what's the derivative of this behemoth of a thing? So what's the derivative of this? It's a bit difficult in it. But let's try finding the derivative of x to the n over n factorial just normally. So what's the derivative of x to the n? What's the derivative of x to the n? That's just going to be n times x to the n minus 1 over n factorial. Right? So, yeah. And then we can simplify this to be, since n factorial is just n times n minus 1 factorial, we can cancel n from numerator and denominator in order to get x to the n minus 1 over n minus 1 factorial. Now, 0 factorial exists, that is 1. But negative factorial cannot exist. So we cannot start from n equals 0. We cannot start from 0. We have to start from 1. So that is what we're going to do here. N starts at 1 and then goes to infinity. There's a much more complicated world out there, but that's basically it. We cannot start at 0, so we have to start at 1. So what we're going to do, what does this mean? Well, let's substitute n minus 1 to be k. All right. So what does that mean? Well, we know that if n equals 1, then k is equals to 0. So let's substitute. It still goes to infinity because we're not changing anything normally. It's just a constant. So k is now starting from 0. X to the, what is this? Going to be k over n minus 1 is now k factorial. This and this are the same thing, different letter. So this is also e to the x. So we just proved that the derivative of e to the x is e to the x using the power series representation of e to the x, which is amazing, kind of amazing, you know. So yeah, that's 11 questions done. I hope you learned something about exponents today, and I'll see you in the next video. Bye. If I have anything wrong, please cancel me on Twitter. I deserve to be canceled for having a wrong negative symbol somewhere. Anyway, I'll see you in the next video. Bye.